In our last lesson, we looked at simple interest when you earn interest only on your original investment. Now, because of this, you earn the same amount of interest every single year. Today, we'll look at a different and more common type of interest called compound interest. Now, let's say you have the option to invest $1,000 into either an account that earns 7% simple interest or another account that earns 7% interest compounded annually. Which one should you choose? Now, we'll talk about later on what compounded annually means, but for now, we'll just look at the simple interest. Now, simple interest, I've already filled out this table here. If we invest $1,000, every single year we're going to earn 7% of that, which is $70 every single year. And that doesn't change because it's only on the principal amount that we earn interest. So that means after 1 year, we will have a total of $1,070. So we add the $70 in interest. The next year after that, another year goes by, we add $70 again. And then we add $70 again and again and again. So over a 5-year period, we're going to end up with $1,350 with simple interest, and that's by adding the $70 every single year. So what does compound interest mean? With compound interest, you earn interest on your original investment and any interest you have earned so far. That's the key difference. So any interest that you have earned so far is added to your total, but you also earn the percentage on that amount as well. So to show you in this table, again, we're starting with $1,000. That's our amount at the start of the year. The very first year, again, we would earn 7%, which is $70. So after 1 year, you'll see that it doesn't make any difference at all. We still have $1,070. Now, where this becomes different, at the start of year number 2, now compound interest says that we have $1,070, and we will earn the 7% on that. So 7% of $1,070 is now $74.90. So a difference of $4.90 from before. So our total is a little bit higher if you compare it to the simple interest table. So again, at the end of year 2, that becomes our total at the beginning of year 3. And we earn the 7% on that amount. We're now earning $80.14 in interest for a total of $1,225.04. Now, at this point, I'm rounding to 2 decimal places because it's money that we're talking about. So just going on further again, we now earn 7% on that amount, and then 7% on that amount, and we have a total of $1,402. So if you take a look at the simple interest table, $1,350, we've earned about $52 more with compound interest. Now, taking a look at the actual interest amounts, again, for simple interest, it was $70 every single time, but with compound interest, it gets larger and larger. So $4.90 more, then about $5.20 more, and so on and so on. So not only is it increasing, it's increasing by a larger amount each time because our principal amount is increasing every single year, the amount that we earn interest on. Now, when we deal with compound interest, we don't have to come up with a table like this every single time, because what if I said after 20 years or 25 years, we don't want to go through 25 rows. Now, if you think about it, we have actually done calculations like this before, a shorter way. This is actually an example of exponential growth. So the compound interest formula is exactly like the exponential growth formula that we had earlier on. Now, for compound interest, we're going to be calculating the future value or the total amount. This formula does not give us the amount of interest, it gives us the total amount. So we take the principal, which is like our initial value, we multiply that by 1 plus I to the power of n, where I is the interest rate. Now, I'll talk about what per compounding period means in a moment. So 1 plus I means that we are increasing by that percentage, and to the power of n means that many times we're increasing. So how many times are we increasing? Now, n officially means the number of periods, which is the number of times you earn interest. Now, it's not going to be like simple interest where it's simply the number of years. Compound interest can work in different ways, and how it works and what compounding means is that the interest can be divided up throughout the year. Now, the example we just saw was compounding annually, which is once per year, so you only earn interest once per year. If interest is semi-annual, now semi is, if you divide into two, like a semicircle, that's twice per year that you earn interest, which is every 6 months. So after 6 months go by, you would earn interest. After 6 months goes by again, you would earn interest again, so twice in the year. Quarterly, 4 quarters in a dollar, means 4 times per year, which would be every 3 months you earn interest. Monthly is once a month, so 12 times per year. And interest could even be daily, which is 365 times per year. So basically every day, and we kind of assume no leap year if we're doing that. Now here's the thing, it would be great, like if the interest rate was 7%, it'd be great if you earned 7% each day. Your money would grow so fast, but it doesn't quite work that way. You have to divide the interest rate by the number of times per year that interest is earned. So for example, to figure out the interest rate per period, if we have 4% compounded semi-annually. Now I'm going to be expressing, and we use a lowercase I for the interest rate for compound interest, I'm going to be expressing 4% as a decimal 0.04, but I'm earning interest twice per year if it's semi-annual, so I have to divide this by 2. So 0.02. Now what this means is you earn 2% twice a year. Now, in total, this gives you 4% for the whole year, but it actually works out to be a little bit higher than that. So if you understand how percentages work, if I give you 2% of your amount of money and then 2% of that amount, it's going to work out to be a little bit higher than if I just gave you 4%. It's going to grow a little bit faster. Now, same idea, 6% compounded quarterly. So again, 6% is 0.06. If it's compounded quarterly, that means 4 times per year. So divide by 4, and I get 0.015. So about 1.5% every 3 months. All right, so now we'll take a look at some examples. So we have to remember for compound interest to divide our interest rate depending on how the interest rate is compounded. But we also have to figure out what n is, and n is going to represent the number of times you earn interest. So let's say Betty is going to invest $500 into an account that will give her 6% interest compounded monthly. How much will she have in her account after 3 years? So the principal amount here is $500. That's what she starts with. Now the interest rate is 0.6. So 0.06 for 6%. And it's compounded monthly. So she's not going to earn 6% every single month. We're going to divide by 12. And we get 0.005. Now, I'll try to give you interest rates that will divide nicely. So this is exactly 0.005. If it doesn't quite work out, I'll tell you how to round it. Now, 3 years are going by. So when we figure out n is not going to be simply 3. You have to think how many times she's earning interest. Now, she's earning interest every month for 3 years. So what we do is 3 times 12, she'll be earning interest a total of 36 times. 36 months are going by. So just like with exponential growth, the exponent represents how many times this is occurring. So in our formula, just like exponential growth, 500 times. Now you don't have to show me 1 plus, you can just put 1.005 to the power 36. And we are normally going to have to round our answers here, so always give me 2 decimal places. So this will give approximately $598.34. There's our final answer. All right, so next question. Nicole borrows $15,000 from the bank, and she'll be charged 14% interest compounded semi-annually. How much interest was she charged in 2 years? Now, the principal amount here is $15,000. This is how much she's borrowing, and she's going to be charged interest on top of this. Now, the interest rate is 14%, 0.14, and it's compounded semi-annually, so we have to divide that by 2. So 7% interest she's charged every 6 months. Now, 2 years are going by, but she's not getting charged interest only twice. She's getting charged interest twice per year for 2 years, so n is equal to 4. So piecing together the equation, we got 15,000 times 1.07 to the power of 4, and this will give us a value of 19,661.94. Now, if you've been really paying attention, this is not going to be our final answer here, because what the question is asking is how much interest was she charged in 2 years. This is the final amount that she has to pay back. That's not the amount of interest that she was charged. So what we can do is, to calculate the interest charge, we'll use a capital I, just like with simple interest. We can take that final total and subtract what she initially borrowed. So the difference between those two values is how much was added, or the amount of interest. So there was a total of $4,661.94 in interest charged during that time. All right, so last question. To save for a class trip in 2 years, Nadia invests $500 into a savings account that will give her 2% compounded quarterly. How much will she have in 2 years, and will it be enough for the $600 trip? So let's take a look. So the principal amount, she has $500 to invest. The interest rate I, so it's 2%. So she's not getting a very good interest rate here. And it's compounded quarterly, which is 4 times per year, divided by 4. So we get 0.005. Now, for the number of times she earns interest, it's for 2 years that she's investing, but it's 4 times per year. So a total of 8 times that she'll earn interest. So piecing together our equation, 500 times 1.005 to the power of 8 will give us a total of $520.35. Now, the question does not just ask you how much will she have, it also asks, will it be enough for the $600 trip? So I would like a concluding statement to a question like this. So therefore, she will not have enough for the $600 trip. If you want to include how much she was short, you could do that, of course. So she'd be short about $79.65. You can include that if you want, but basically she did not invest enough money to earn that amount of money at that interest rate.